Hello and welcome to this video on constructing a valid C program. So in the last video you might remember that we copy pasted this line of code to test our C compiler, and in this video we're going to really learn how to construct this code from scratch. So if we start with a blank document here and save that, let us begin. So if you think about it, the way programs really execute on a modern computer is that the user is running the operating system, so maybe the processor is executing the code inside the file explorer, and then the user says, hey, I want to execute this particular program, so maybe they double click on it or something like that, and then the operating system says, okay, and starts executing our program code. But where in the mess of ones and zeros that makes up our program should the execution begin? So you might think one solution to this is to start executing from the start of the file and just go right the way to the end of the file. Now, this might work in some situations, but modern operating systems require some data at the start of a file that tells the operating system a bit about our program. For example, the versions of the operating system it was designed to run on. So what we do instead is in this section of data which the operating system reads about our program, we specify what's called an entry point, which is the point at which we want the operating system to start executing our program. Now, taking a slight detour, a function in the C programming language is just a named section of code. So maybe we have a named section of code called print hello, which contains the instructions to print the words hello to the screen. So when we want to perform this named section of code, all we have to do is what's called calling the function, which results in the processor going off and executing that section of code and then returning to where we were before. Now, functions can also return values. So let's say we had a function called add 5 and 10, which contains the instructions for adding the numbers 5 and 10. Then when we call the function add 5 and 10, we can actually get a value back. So in this case, maybe we would call the function add 5 and 10, and we would get returned the value 15. Now, functions can also take values called parameters, which we're not going to discuss in detail right now, but pretty much instead of calling the function add 5 and 10, maybe you wanted the function add two numbers, and then you specify those two numbers when you call the function. So maybe you could specify add two numbers 5 and 10, or maybe you could specify add two numbers 3 and 2, and it would go off and execute that named section of code with the values you specified. Additionally, there are many standards defining different versions of the C programming language. If we take a look at the C99 standard, section 5.1.2.2.1, it says the function called at program startup is named main. So what that means is in the C programming language, if we write a function, so that's a named block of code, called main, then the language will ensure that this is the function that gets called first and is our entry point. If you're looking for definitive information on anything about the C programming language, the language standard is always a fantastic place to look. So, if our compiler abides to this C programming language standard, then we can write a function called main, and we know this is going to get executed first. Now, I should mention there's some ambiguity when I'm using the word compiler here. So I've been using the word compiler thus far to mean something that takes our source code and outputs our final executable. But realistically, this process consists of several components, one of which is strictly speaking the compiler, which takes our source code, our program code, our C language code, and translates that into machine code, which we've discussed previously, and another of which is the linker, which deals with linking different pieces together, something we're going to discuss in much more detail in future. If I try compiling an empty file using Clang, for example, we'll actually see that the error we get is a linker error, because the linker failed to hook up the main function properly. On this tangent, it's worth noting that both compilers and linkers have a number of options which you can pass to them to modify aspects of their behavior. For example, compilers often have different optimization flags which you can pass to them to change the level of optimization that the compiler automatically performs on your code. But going back to where we were, let's actually try and construct a main function. So first off, all functions have to specify the type of their return value. Now, we're not going to discuss types in depth right now, we certainly will in future, but essentially values in C have types which dictates the data they hold. For example, whole numbers and numbers with a fractional part are different types in C language. So in this case, the main function typically has an int return type, which means it returns an integer value, a whole number value. So with all the theoretical pieces in place, we just need to know the syntax to express this in the C programming language. If you don't know what syntax means, it's just a set of rules which define what is valid in the language. Just like there's a certain set of rules for how the English language should be written, there's a certain set of rules for how the C language should be written. And these are also defined in the standard. So to write functions in C, we first write the return type. In this case, we've discussed we want it to be the integer return type, the whole number return type. And we do this by typing the int keyword. Then we specify the name of our function, in this case main. Now following this we have some parentheses. Now in these we typically specify details about the parameters that our function takes, but in this case we actually don't want the main function to take any parameters, so we're going to write the keyword void, which just tells the C compiler, yeah, we don't want to take any parameters here. And after that we have some curly brackets. Curly brackets in C typically represent sectioned off portions of code, and in this case, all the code within the curly brackets is code within our main function. So now we can type stuff inside of it, and it belongs to the named section of code called main. And now the final piece of the puzzle, we just need to tell our main function a value to return, because we specify that it's going to return a whole number. We just need to specify what value it is that we want to return. Now the C99 standard defines the return value of 0 from main to mean successful termination, and so that seems like a good candidate here. So what we have to do to return a value from a function within the syntax of the C programming language, if you write the return keyword, then whatever we want to return, in this case we want to return a whole number, so we can just type the number, like 0, and then we write a semicolon to end the line. Semicolons in C are typically used to indicate the end of a statement, which is a standalone action to be carried out. So in this case, the semicolon says, okay, we've returned 0, that's the end of that particular thing that we were doing there. Also, super quick side note on formatting, you might notice that I put a tab space here before this return line. Now, why did I do that? Well, we don't actually need to do it. I could remove it and it would work just fine, but typically it's considered good practice in terms of formatting to tab indent, or space indent if you prefer. It doesn't actually make a difference, lines within curly braces, because actually this makes it very clear when just skimming the code that this particular line belongs inside this set of curly braces and thus belongs to the main function. So if we actually try and compile this, we see that, hey, we actually compiled successfully, and if we run the program, we'll see that we get exactly what we did previously. Now, strictly speaking, this program doesn't do nothing, as I implied last time. It returns a value, as we can see in the C code. And in my terminal here, I can inspect that return value like this. So we'll see, hey, look, the return value there was 0. Now, if we want, we can actually go ahead and change the return value, so it returns 1. We can recompile, we can rerun, and we can rerun that command which shows us the return value of the previously executed program, and we'll see, hey, it returns 1. It works. So that's really all I had to say in this video. If you think we're going a little slow, then, well, you're right, we are going quite slowly through the groundwork because it's vitally important that you understand these foundations before we build up to higher things. So if you didn't understand anything about the code we just constructed, then I recommend you rewatch this video, or you check out the video notes, or you send me an email, or whatever you need to do just to get this basic understanding down. So that is all for this video. I will see you next time.